how to test and debug a JavaScript application. A lot of this stuff we've looked at already. Like I said, when you're running JavaScript, you click a button and nothing happens. The first thing you want to do is go look at F12. Go look at the console tab. And usually that will tell you where the errors are or give you an idea. If there doesn't show any errors, then you have to go through and debug it. So it's like I was saying, if you come across an error and it doesn't show up on the F12 in the console, then you got to go put some code in to kind of walk through your code to make sure it's firing at the right spots and stuff like that. So objectives, part 1, apply, develop test plans for applications that you develop. Use Chrome's developer tool to debug applications by setting breakpoints, viewing the current data values, and stepping through the execution of statements. Trace the execution of an application with console.log statements. View the source code for a web page. Knowledge, distinguish between the goals of testing and debugging. Distinguish between syntax, runtime, and logic errors. Describe the type of debugging problems that can occur when you use floating point numbers and arithmetic expressions, and describe one way to fix this problem. Describe the type of debugging problems that can occur if you don't use strict mode and JavaScript treats undeclared variables as global variables. In general terms, describe how to create a test plan. Describe the procedures for tracing the execution application with console.log statements. And those console.log statements are just kind of like the alerts that we're throwing in some of them, like I was telling you old school wise. That's how we used to do a lot of it. So testing versus debugging. The goal of testing is QA. If you see QA mentioned anywhere, which you will a lot, because 99% of the time you're going to have some kind of testing team to go back and test your work to make sure it works. QA just means quality assurance. If you go out and look for jobs on the job market, you may see something with like QA knowledge or QA testing. That's all it is a tester. You go test the software, make sure it works, make sure it runs. Let me go ahead and straighten this for you so you don't have to stare at the screen the whole time. Is just make sure it runs. The last place I worked at, I think they had a testing team of 5 or 6 people, and they were all out of Mexico.
Either way, I can't actually imagine being a QA team out there when they're kind of trying to test them, because just like you said, back in on defense or something like that, I'm pretty sure you have like someone or something like review your code and everybody send it back to you.
Well, they did that down there too. So what you do with the testing team, what they do is you code your code out, you think you're done with it, you send it over to the testing team. The testing team does everything they can possibly do to try and break your code, whether it be banging their forehead on the keyboard or putting in absolutely terrible data to try and get it to break. That's their whole job, is just trying to find issues with your code. The more issues you have with it, the worse it looks on you as a developer that you're letting these errors get through without testing them yourself before you send them over. Most of the time, if they find something, they write it up as a defect. They send it back to you. You got to go fix it. So you try and keep those down to a minimum so it doesn't look bad against you as you turn all this stuff in. So like it says here, quality assurance testing to find all errors before the application is put into production. You mentioned Department of Defense. The first contract I worked on, at one time they probably had 30 or more testers on a team to test our software. We were turning so much in of it at one time, and we did a style called waterfall development. So we'd work on something for 6 months and then turn it over to testing, and they would take however long to test it, probably 3, 4, 5, 6 months to test it. Whenever they'd find errors, they'd send it back to us and we'd have to fix it right away and stuff like that. As the contract moved along and we did less and less coding on it, the team ended up dropping down to maybe 6 to 10 people, I think. But each one had a section that they tested, and that way they were familiar with it and knew what kind of data to put in and try and do everything they could to break it and stuff like that. So Goal of debugging, to fix all errors before the application is put into production. And that's like we've been doing in this JavaScript. When you run your code and you click a button and it doesn't work, you try and go in and debug it and fix it and get it running right before you turn it into me to grade. I'm like the testing team. I test your code to make sure it follows the rubric and does what it's supposed to do. Fortunately, you lose points on it when you turn it into me. I guess technically you could lose points at a real job because you get dinged when you get a whole bunch of defects turned over to the testing team and stuff like that. So. You want me to start yelling at you and throw forks and knives and stuff? So the 3 types of errors that can occur: syntax errors. They don't follow the syntax rules of a language. So like if you do a to-fixed and you use a capital T instead of lowercase t, it can throw an error like that. Just syntax stuff that it's supposed to be coded a certain way for the system and you don't code it that way. Syntax error. Runtime errors. Program is actively running, but part of it isn't working properly. Full HD, full RAM network connection isn't made. Credentials for DB are incorrect. So as you're trying to connect to a DB and something doesn't work, it could cause a runtime error, stuff like that. You will run across those quite a bit too as you're working. Something could go wrong. You can't connect to the network properly, you get the runtime error. And then of course finally logic errors, mistakes that developers make solving a problem, spelling errors, math errors. And you see both of those quite a bit too. Spelling errors, you spell your variable one way, as you're trying to use it you spell it a different way and it doesn't work, you get an error with it. Math errors, you're trying to you add something before you should be dividing it and it throws your math all off and stuff like that. We've all seen those in these labs and stuff we've been working on. We come across those constantly. So syntax, runtime errors, and logic errors, you will see those a lot as you're doing software development. Nobody's perfect at development, so more than likely you'll come across something. Runtime errors, sometimes they're kind of out of your control, but the logic and syntax errors are definitely more in your control, things you need to keep an eye on as you're coding. Try not to let those happen. If you do happen, get them fixed before you turn them over to testing, and don't get yourself dinged by the bosses. The future value applicator with a logical error. You can see the future value is like super large and it shouldn't be close to that. Common syntax errors: misspelled keywords like coding query selector instead of query selector. You can see it, they put the E at the end here instead of an O. Just fat finger it. You'll do that a lot of times as you're coding and doing it fairly fast. You may hit one key over compared to what you're supposed to be doing. Omitting required parentheses, quotation marks, or braces. You see that a lot. We've run into that a lot as we've coded JavaScript and C# stuff. Common, and then like I said, if you forget one of those, especially a parentheses or a braces, it can be a pain to go back and dig through them. Now with today's IDEs, a lot of them will point out where that problem is or let you know that you forgot something in your code to get you to fix it a little bit quicker. Back in the old days before IDEs were super smart, you'd have to go through and try and match them all up by hand by walking through the code to see where you missed like a curly bracket or a brace or something. It was not fun, but now the IDEs are getting so smart that most of them will point it out to you or have some kind of marking or something to show you where an opening and closing ones are that you can catch. Not using the same opening and closing quotation marks. If you use a single quote and then a double quote, that can throw errors and stuff like that. So usually when you start using one, stick with it all through your code, and that way you don't have those issues. Omitting the semicolon at the end of a statement. JavaScript's a little more forgiving with that, but as you get into coding Java, C#, you got to have those semicolons at the end of your code to make sure your code runs properly and you don't cause an error with that. Misspelling or incorrectly capitalizing an identifier, like defining a variable name sales tax camel case and then referring it later as sales tax with that T for tax in lowercase. See that done a lot too. As you're coding, you define your variable, a global variable more than likely, at the top of your code. As you get back down to it, you think you remember how you wrote it, but you can't remember, and you code it out, and then it ends up being a spelling mistake or something like that. That will happen quite a bit. You think you call it sales tax, but you call it sales something else. That kind of stuff as you're going through. Yep.
I was wondering why. I think one of our labs, I think you're well, not it had to be nothing lab. Back in C#, I noticed that when we're doing the whole sales tax, why do we kind of have it all in caps? But we don't have like that little dash minus on it.
Usually when we had it in caps, it was what they considered a constant.
Yeah, it was a constant.
Yeah, so that's why they put it all in caps. So when you looked at it, you knew it was a constant. And C#, they don't really declare the constant like that. In JavaScript, we call it a constant, so we know it's a constant, so you don't necessarily have to capitalize it to point it out. Problems with HTML references, referring to an attribute, value, or other HTML component incorrectly, like referring to an ID as sales tax when the ID is sales underscore tax. And like I said, you'll see these mistakes quite a bit just because you forget as you're coding along or something like that. And that's why they tell you if you start with camel case, stay with camel case. If you do, I think it's called snake casing, stay with that with the underscore. That way you know as you're coding there's one less chance of screwing something up by sticking with whatever type of casing you're going to use throughout. Problems with data and comparisons. Not making sure that a user entry is the right data type before processing it. That goes into a lot of validation stuff. That is not a number, checking to make sure they're actually putting a number in or vice versa. JavaScript, it's not as bad because you're not really picking data types as much as like you would in C# and stuff like that. Not using the parseInt or parseFloat method to convert a user entry into a numeric value before processing it. That one you'll see a lot. You may use a parseFloat when you should have used a parseInt, and it'll put a big long decimal point value in your code, and that's not what you want. You just wanted a whole number, so you got to make sure you're using the parseInt or parseFloat properly. Using one equal sign instead of two when testing for equality. The beginning students, I see that a lot in. If you put one equal sign, what's it actually doing? Yeah, it's assigning a value to the variable instead of comparing it. So that's something you got to keep in mind, but as you write code over and over again, you'll get very used to it. And Java, you got to use like a dot equals to get it to actually do that kind of calculation there, the comparison, instead of using equal sign. So as you get more in your coding career and that and see different languages, there may be different ways you need to write it, but just remember, one equal sign, you're assigning a value to it. Two equal sign, you're doing a comparison for equality testing. Problems with floating point arithmetic. The number data type in JavaScript uses floating point numbers, and that can lead to arithmetic results that are imprecise. For example, got a variable sales amount equals 74.95, sales tax with the sales amount times 0.1. The result is 7.95. You can see the long decimal and stuff like that. Way to fix a lot of that. One way to fix a potential problem is to round the result to the right number of decimal places. If necessary, you can also convert it back to a floating point number. So that sales tax here, they're doing a 2 fixed. Using that 2 fixed cuts it off at 7.49, and then it'll round it up. Should be 7.50 because we're going to round that 5 up once we use that 2 fixed. And again, you can see down here it is doing that 7.50 as a string. Sales tax parse float, 2 fixed 2, and we get that 7.5 as a number. So just keep that in mind, that using that 2 fixed, whether it be a number, being a string, what you need to use for it.
You can also get rid of a decimal too.
Yep, if you use that %, and stuff like that.
Yeah, but also with 2 fixed, you put like a 0 on it, it can also kind of get rid of the entire decimals completely.
Yeah. Problems with undeclared variables that are treated as global variables. If you don't use strict mode and you assign a value to a variable that hasn't been declared, the JavaScript engine treats it as a global variable. So in this example here, have a constant, they give it a calculate tax as the name, they do a function here, subtotal and tax rate's a parameter they're passing in, and the method body or function body here between the curlies, they're saying let sales tax equals subtotal times the tax rate. Sales tax is local. Sales tax equals parse float. Sales tax to fixed. The sales tax ends up being global here because they're not declaring it. And so then it returns sales tax. Sales tax isn't rounded, but sales tax is. And you can see our let has it one way with the camel casing. Our sales tax here does not have that camel case, so that's why that one's global. This one gets declared as a let inside the body, so that one's a local. And then it returns that sales tax as global. And so you got to be careful of that, the way you word it, where you're declaring them at, to make sure you're using your local compared to your globals, depending on what you're trying to do with it. The solution to this type of problem is always use strict mode, and that's why we've been trying to get in that habit of using strict mode.
I kind of made a little mistake in my lab, but sometimes I also be using script mode, sometimes not strict mode.
Script mode?
Yeah, I'll sometimes use that instead of be like, huh? Wait,
and so then when we look at that, what's that? That's a syntax error. You're putting the wrong thing in, or it could be a logic error because you're putting the wrong thing in. But anyway, it's an error, so something to keep in mind. Strict mode. You got to be strict. You got to be strict. Don't let anything slip through that JavaScript code. The future value application with valid data. You can see they got it cleaned up, and now you get an actual number that you're expecting down here compared to that first example we looked at. Future valid value application with invalid data, and here they do some validation, and as you code your code through your career, you're going to always be putting validation on stuff, just one less chance for an error or something wrong to slip through your code. So you'll be doing checks on values, you'll be doing checks on data, all kinds of stuff to make sure, checks to make sure something's not blank, all kinds of validation steps you'll be taking eventually in your coding career to make sure this stuff gets caught before it slips through and breaks something, causes an error. In this full stack development that we do, you'll have validation on the front end, you'll have validation on the middle tier, you'll have validation on the back end, and all that works in conjunction to try and make sure a bad value in the front end doesn't get passed all the way to the database and end up breaking something or corrupting your data in one way or another. 2 critical test phases. Test the application with valid input data to make sure the results are correct. Test the application with invalid data or unexpected user actions. Try everything you can think of to make the application fail. So what they're saying there is, as you code your coding out, or as you're coding your application out, you get done with it or part of it done, put numbers in you know are going to work. Like our rubric shows numbers on them. Use those numbers first to test it. You know, the rubric's showing it, it should work. Test it with that. Test it with numbers you know will work on it. Once you know that's working with the numbers you're sure of, go put in odd numbers or go put in letters or a string and see if that can cause it to break. If that causes it to break, fix it. Go put validation on it to catch that stuff and make sure the user's putting in what you're expecting. And like I said here, let's try everything you can think of to make the application fail. I think some of the testers I worked with just take their fists and pound on the keyboard, half out of fun, half out of test, half or third out of fun, test, and anger, to do whatever they could to make it break. I mean, they try everything. If they're a good tester, they will put every kind of value or everything they can possibly do to try and get that thing to break, to make sure it doesn't get released out in the field like that. How to make a test plan for the critical phases. List the valid entries that you're going to make and correct results for each set of entries. Then make sure the results are correct when you test with those entries. List the invalid entries that you're going to make. That should include entries that test the limits of allowable values. What they're saying there is you're testing this stuff out. Make notes of the data you use to get it to work properly. And then as you break it, write down the values you use to break it. And that way you can check later on to make sure you catch it or it's fixed, that it doesn't break with those. I know, like, when you work with the testing team, back in the day when I first started with them, they would write a paragraph out of what they did to do it. Brought up the app, I logged into this, I brought up this page, I filled out this with all this data, and they tell you the data they used. I clicked on the button. When I clicked on the button, it broke. It highlighted this. And so then you'd have to go back through, walk through all that code, test it all again with what their steps were to break it. Then you'd have to go look at your code and see what the difference was in your code that caused it to break, and then go fix it. So there's a lot to it, a lot involved, but you gotta have this part to make sure your stuff goes out to the public with no errors, no possibility of breaking. I mean, bad software, that's gonna turn a lot of people off. Websites with links that don't work, or a form you're trying to submit and it breaks your website or crashes your whole website. That will turn customers off from coming back to your websites, and you do not want that. You want people coming back to your sites and using your software and everything else. So you hear a lot of people complain about Microsoft and Windows and stuff because it crashes so much and it's buggy and that. And
oh man, Windows 11 does not work on my computer at all.
yeah.
Like, don't get me wrong, it looks nice, but it just, when it comes to playing like games on it, there's certain games and certain bits that can run this computer, otherwise it'll crash my game that it's in.
Yeah, so there's a Windows application. I mean, it does tons of stuff, so there's probably so much testing that should go into it. I know a lot of places probably don't test as well as they should, just to get it out to the public, get the new stuff out, and then a lot of times they'll let the users find issues and then send in a bug ticket or whatever, and then they'll go check it and fix it and send it back out with a release. And so you'll see all these updates. A lot of times you start your computer up and you get updates. That's what some of it is they fix some of these bugs that they came across out in the real world and fix them and send out a new release to get them fixed to the public and get their software running a little bit better, whatnot. So you'll see that a lot of your updates, that's what they're doing. Even like Visual Studio Code we use, sometimes you'll see it says you need to restart it to get the updates on, and then you can go look through wherever they put it and they'll tell you what bugs they fixed and stuff like that. You'll see that on a lot of software. The bugs or updates, your Xbox games and stuff like that, you know, they're constantly patching those. I know Call of Duty, which I play a lot, constantly getting updated because there's bugs and glitches and stuff like that that they're trying to catch and fix.
Yeah, but the only issue is I can't download anything on my Xbox. If I'm at the door, I can only download stuff like here, and that sucks. So that's like my PS5 right now. I can download anything, but when it comes to Xbox, I can't download anything at all.
Too slow, or?
No, it ain't even that. It's not even really that. It's just like, for whatever reason, it's like they got some type of limiter of like how much they can download on your Xbox. And I got the Series X, and it's just, when I try to download like a whole update Call of Duty that had like 37 gigs,
Yeah.
it's like the Wi-Fi is sounding like, it's kind of like forcing you to download anything. And they go up at like a certain number, and it just sucks.
Bring it in here in the morning and plug it into the wall.
Yeah, I can do that too.
2 common testing problems: not testing wide enough range of entries. and not knowing what the results of each set of entries should be and assuming that the results are correct because they look correct. So again, that goes back to when you test, make sure you put a wide range of entries in. Don't just limit it to a few things. Do as much as you can think of to get it done. Numbers, text, whatever it takes, make sure you put a wide range of different entries in. Don't just put 10 and 2 in and stop it at that and like, okay, it comes up to 20 or whatever, and okay, that's good. Same with not knowing the results of each set of entries. You run it, you don't know the math for sure on it or something like that, but it returns an answer and it said, okay, it returned an answer, that's good enough for me. You need to make sure it's the right answer that it's returning, not that it's just returning something or your button clicks and it does this or that. You need to know what the entry should be and what kind of result you should be expecting back from those entries, whether they're correct or not correct. Because if you just assume they're correct, it might not be right, it might go out. You could be doing something for a financial company, and I think in the C# class we watched that video for the medical company that they did something and it ended up killing a bunch of people because the guy's math calculation was off, but they didn't test it well enough to catch it. Went out to the public, it killed like 8 or 10 people because one little math calculation was off and they assumed it was right, didn't dig into it much. And so, I mean, that's a big issue like that. But I mean, even little things, like I said, you know, a small math thing can cause a lot of problems. Your financial records, you know, short you money and stuff, something like that. Stuff you don't want out to the public. Terms related to testing and debugging: test, debug, bug, syntax error, runtime error, logic error, throw an exception. And we were C#, we were handling exceptions and throwing exceptions in C#. An exception is an object that is generated when a problem occurs that can crash your software. Like I said, you try and handle those. You don't see them as much on the web stuff, but on the C# and software development, you'll see that a lot. Java, you'll see that a lot. C#. But you try and catch those exceptions so it doesn't crash your software, and you try and get the user to put in the proper thing. Throw an error is a problem that can be fixed with an if, else, and loops. So that's just an odd way of putting it, but yeah. Problem can be fixed with if, else, and loops. So you can go through and you can see almost like a validation thing is what they're trying to stop from an error from happening. So while number is less than 0, prompt the user for a number again. So it goes into the validation kind of a thing. And like I said, as you code, no matter what, you're going to be validating anything data-wise that can be put in your program. You're going to be validating it to make sure it's the right type of data, and they're not putting numbers in when it should be a string, or a string when it should be a number, and a negative number when it should be a positive, all that kind of stuff. So Chrome with an open console panel that shows an error. And we've taken a look at a lot of this stuff. Let me see if I have a website up that we can look at. Nope, all my stuff closed. So let's bring something up. As this decides it wants to run. That took a while. So we have our so we can do inspect. And this brings up our console. You can see we have a console here. We can click on that. Failed to load resource. The server responded with the status of 404 not found. And that's for a favicon thing, so that's nothing to do with our code. So you can see that and be like, okay, that's got nothing to do with what we're looking at. Or you can hit F12, which is the developer tool opener. It says the same thing, console. We looked at some of this stuff with the CSS and HTML. We can go over and look at all that if we need to. I think as we go through these slides, it'll kind of talk about that again as a refresher. But the console elements, sources, you could probably use a lot just to kind of see where you're looking at for your code. And I know as we get into the React stuff, we'll probably use sources a little bit more just to see how it's all hooking up. But that's how the F12 developer console looks. You can do it that way or the inspect here. Like I said, as you're developing JavaScript, HTML, this developer tool will become one of your best friends just because you'll use it so much. And a lot of people leave it up as they code just to see what's going on with their code as they're running it and stuff like that. So here's an example here, the future value calculator. They got an uncaught reference error, is not a number, is not defined. I don't know if they'll show it. At is valid value, and then it shows you what line of code it's on. And you can look through it that way. 3 ways to open the Chrome developer tool. F12, Control-Shift-I, click on the menu button in the upper right corner of browser, select more tools, developer tools, or that inspect that we looked at, so we need to add that on there eventually. 2 ways to close the Chrome developer tool. Click on the X in the upper right hand corner of it, and that's right here in the upper right hand corner. You can see it says close dev tools, or you can hit F12 again and that gets rid of it. The sources panel after the link in the console panel has been clicked. Just took a look at that sources part of it, or the sources. Did it say sources? Yeah, the sources. So as you have an issue, you can click on it. I don't even know if it'll work on here, but so you can see it opens it up, and you can dig through your code. And if you have an error, you'll see the red X at the end. You can hover over the red X and it'll tell you what the problem is. Shows that red squiggly that you have that issue. Nowadays a lot of these IDEs are getting good enough that they should give you a squiggly, or maybe an issue will show up and you'll see that red squiggly on your IDE. You know there to go fix it before you even have to go look in the console and start checking around in there. How to find the statement that caused the error. Open the console panel by clicking on the console tab. You should see an error message along with the line of code that caused the error. And that's what it was showing in this one here. You can see the line of code that caused it. Future value.js, line 5. And you can see here, we look at it, we're in future value.js. You can see it kind of on top up there. And then it's line 5. We look at line 5, 1, 2, 3, 4, 5, and look at line 5 and say, what's wrong? Oh, here's the red squiggly. That's my issue. So click on the link to the right of the error message that indicates the line of code. That will open the source panel and display the code that contains the statement. Hover over the cursor over the red X for more information about your error. You can see they're doing that there. And then it says uncaught reference error, is not a number, is not defined. So I think because of that vowel there, maybe. A breakpoint in the sources panel. So you can go in here and you can go in your sources, and just like we did in C#, when we debug, you can click somewhere in your code and it puts a debug method in here. So then when you rerun this code, make sure I'm somewhere. That's not where I want. Let's see if we can find. I'll stop it here because the way it's set up. That's not even let me put it in there because it's technically not a script. So let me see. How do I want to do this? Yeah. But anyhow, you can click in there. Oh, it shows us on our script. So let's run it here, refresh it, and see if we can drop into our JavaScript stuff. And it should run in here, hit the line that we have the red dot on, stop it. And again, like I said, this is all stuff we've done in C# before, so it shouldn't be too big of a different thing for you. You're just using this developer tool F12 piece instead of doing it on your actual code or in your IDE. You can see here, marking the line, and then like I said, it'll put that red dot to show you where you put your breakpoint and stop it at. How to set or remove a breakpoint: click on the Sources tab, display the Sources panel, then click on the JavaScript file in the left pane that you want to debug. In the center pane of the code editor pane, click on the line number in the bar to the left of the statement. This will add a breakpoint or remove an existing one. So removes it. It's not dark. You can see it's kind of light colored, so we haven't set one yet. Set one, now it's dark and you can see it. This code here all gets added in by this live server we're running, so it's nothing we're going to really mess with. So click on it again and it's gone. There's no breakpoints now. The buttons and keys for stepping through the JavaScript code. Step into is a left F11. Step through the code one line at a time. That's what you'll use more often than not. That way you can check each line of code as you're walking through it. F10, step over, run any called function without stepping through them. If you know it works and there's not an issue with it, you can use that F10 and step over it. That way you don't actually have to walk through all the code that you know is actually working. And then Shift plus F11 steps out, execute the rest of the function without stepping through it. So it kind of gets you out of that debug line by line thing and gets you back into the code, runs through it. And then again, F8 resumes, that stops all the debugging, just kind of lets your code continue to run out as it needs to run out to finish the application. How to view the current data values at each step. Hover the mouse pointer over a variable or constant name in the code editor pane. View the current values in the local section of the right pane, debugging pane. Click the arrow symbol in the watch section of the debugging pane. Click the plus sign that appears and the type of variable or constant name or expression that you want to watch. The values are also displayed in the right of the declarations of the code editor pane. So you can see over here is where they're talking, is where you'll see some of the stuff show up. So if we hovered over sheets, I thought maybe it'd show us. But like I said, this is all the live server stuff. So we won't see as much. Here's the watch that they mentioned, and you can put variables in there to watch them. And usually you can see that. The console will show some of it. So that's how you can see the values and stuff on it. I know that's not a good example, but that's what you'd do. Trying to see if I can get something to come up. But anyhow, that's how you would do it if you come across an error. And like I said, as we get in this Chapter 5 labs and homework, we'll be debugging, so you'll have a chance to actually work with it and see how it works. Terms relate developer tools is developer tools itself. F12 tools, which is the developer tools. Breakpoints, setting breakpoints and stepping through the code. It's just walking through the code line by line to make sure everything's working how you expect it. The values are what you expect, and that is you code through. One method of the console property of the window object. So you have log and then a string. So what you can do is this console.log and then put whatever you want to in here. They put, in this example, they're coding two log methods that trace its execution. So the first one they have here is this console.log, calculate future value function has started. You'll probably do this quite a bit, and what that's doing there is you put it at the very top of your function that you're writing. So here they have constant, they give it the name calculate future value, and they're doing the arrow function here because we see our little arrow. Stuff in the parentheses is the parameters they're passing through. And the first line of code in their method or function that they did here is this console.log. That just checks to make sure you actually get into the function. So there's times that you call a function and it may not call it. If you don't hit that line of code there, you'll know right away that you're not in your function call that you're setting up. So then you got to kind of figure out why you're not getting into your function. So this will show you whether you're in your function or not. And then down here they do this console.log, and they're doing the string literal, or as we called it in C# string interpolation. I like that word a lot better for some reason. And here they're saying they're assigning the value there to show what I is coming back as. Here they're putting the future value in here, and then they're calling that future value variable to see what value that is. So that's how you check the values that are coming back. So if you want to see what the value of I is, that's how you'd write it. You want to see what the value of future values is, that's how you write it. You run your code, you go out and look in your console here, and it'll show your values up in there. So if we do go in here and do so the first one that they did was just coming into our method, and so we can do something like this. Here we can do, I'll do that. The other one value. We call it, and see, this is, like I said, if you forget what your variables are named, that's a way to cause yourself an error. We're not going to worry about the to fixed on it. We'll just see what it brings back. We'll save this. We got our stuff up, and you can see the page loaded, and the way we have our code set up, it starts firing our function off right away because of how in our HTML puts that on there, and then it runs our script. So as it runs that script right away, in our script here, in our JavaScript, the very first thing we have is our console.log, entered the first do statement. So you can tell right away, entered the first do statement. So that's a good sign. We know our function's starting to run. We're in our function. It's starting to go. Click on 10, 7, 5. We'll do it 5 years. And now you can see our I for the first year, it gets our values. I for the second year gets our values, third, fourth, fifth. And you can see, since we didn't do our to fixed, our numbers get really wonky, and that's why you want to use that to fixed to keep those from getting out of control and possibly messing up your values and stuff like that. You can see the lines that they ran on. That first one was line 6. If we click on it, it should have taken us to line 6. And then we have the other one set at line 31. So if we look at our code, line 6, we have our first statement. That's what it showed. Line 31 is that other log statement, and that's what it showed. So that's, you click on it and it should take you to that point in your code to look at it. But maybe that's a bug that we need to send into Chrome to fix. If they tested it right, they might have caught that. But anyhow, that's console.write or console.log. That's what console.log will do for you. Is you can run it and check your values on here if you want. Like I said, the old school way we used to do it was put alerts in here. So you could do, let's see if string interpolation works. The alerts. Refresh it. And again, we get our first do statement. And then an alert pops up, and then we'll probably have to click through it 10 times to get it. And you can check your values each time, and you can see they're still showing up on our console because we got that console.log on there. So it used to be the old school way of doing it, was putting an alert. If you feel like doing it that way, you can. And then we stop the thing by putting that no in there, and it gives us our printout. So as you write your code, up here, this console.log where we enter a statement, you can put an alert there, and then that way, as you're first coming into it, that alert pops up. You can see, okay, I hit my statement right away instead of having to go look in the log or have the log up. Up to you. I think they're trying to go console.log more just to make it clean, look good, use the developer tools. And then the log message, and I just showed you the log message that we had, and you can see that's doing the same thing. They don't have that to fixed down there, so it's throwing a bunch of wonky numbers out there, causing some issues. 3 more methods of the console property of the window object, as they have a warn, an error, and a trace. So you can put console.error, value is not a number, console.warn, value is not greater than 0. And you can see if you use the error, it throws this red error up here in your console, so you can test it and check and see what's going on. If it's not a big deal, you can use that warn. Errors usually are way more serious than a warning. Warning, you can usually let them go without an issue. And the warning, you can see it'll have that little yellow there. You probably see that a lot. As you're debugging stuff with your console up, you'll see a lot. And like I said, this one here that we looked at earlier. What did I use on that? I forgot what it was, but we saw that 404 error because of the favicon thing. And it was an error, that's why it was red, so that's how that works. You'll see yellow for warnings. And then finally, console.trace. When you use this console.trace, what that does is it shows how you walk through the code, all the methods you use in that before the error comes up. So you kind of have an idea of saying, okay, we went through the calculate FV future value on line 9, that was good. Future value line 51, could be an error with that, so then they tell you where that came up. So that console trace, you don't use that as much as you will the log. The log you for sure will use a lot. Console trace you don't use quite as much. That console trace is like the stack trace that we use in C#. It just kind of walks through all the steps you took. It traces the steps you took through the code to get to where you got to. Terms relate to tracing, trace execution, and there's that stack trace I just mentioned. That stack trace traces it through the stack of calls that you made to get to where you're at. HTML and CSS for a web page in the Elements panel. We looked at that when we did the HTML CSS part of this course, so I'm not going to spend too much time on that. Again, our elements, there's our H1. Shows the margin on top and bottom, and then our paragraphs as we go through. So again, looked at that already in previous chapters. How to view the source code for a web page, we know how to do that already. We can do that view page source, yep, and get to that. Open Developer Tools and click on Elements tab. Display the elements of the panel. The panel displays the HTML nodes for a document. We just looked at that. Span the nodes and see till you see the HTML element that you're looking for. If your JavaScript code changes the DOM, such as by adding or removing nodes, the changes show in the Eclipse panel as well. And we'll eventually get into that as chapter 6, walking the DOM, so there's chances we'll be changing some of this stuff, and then you'll see the changes in the console still. To select a node, click on it, and then you can see the CSS that's applied to the element in the styles pane at the right side of the panel. And again, like I said, we've looked at this already. You can see our paragraphs. Here's the styles being used for our paragraphs. We don't really have much doing to it, we just left them as the default. How to view the source code, we did that. Source code, view page source code, view the source code in external style sheet, click on the link. When you view the HTML and CSS in this way, you won't see any changes made by your JavaScript code. And that is it for debugging and testing an application. So like I said, a lot of it we did in C# one way or another. Some of it we've already looked at in the HTML CSS part of it, and then some of it we've used as we've done the labs and stuff. I think we've used more alerts in the console.log, but now that we saw the console.log, if you want to use it that way, feel free to.